Hello everyone, and welcome to this preview of the Parallax. First of all, I'd like to thank Georg Nicholas for allowing us to use this file for the preview. We'd also like to thank all the users who helped us solve some issues that we were unable to reproduce. Their work with us was essential. The new script, in addition to improving the graphical interface, includes fixes for many bugs, beta support for AMD GPU, and other features. In the advanced section, for example, we have added a lock for the settings that often cause incorrect outputs to be generated. If you are an experienced user and want to change them, simply check Unlock Tiling. In addition, there is also hardware diagnostics, which will help you understand whether the installed dependencies are compatible with Parallax. All you need to do is click Run Hardware AI Diagnostic and then Run Test. Another new feature is the exponential performance improvement. Among the many changes made to the backend, now, if the image is too large and live tile preview is enabled, when you start inference on the entire image, Parallax will ask whether you want to disable it. We recommend doing so, because on very large images, tile preview consumes a lot of memory. Star sharpening, or star reduction, has also been significantly improved in the classic version. Stars now retain their natural appearance and information while still looking sharper. The classic mode will continue to preserve a realistic look that is less aesthetic. Many users prefer it because it keeps the stars very flexible for later post-production. Now let's look at defined mode, which introduces 3 new neural models. These models focus heavily on the aesthetics of the stars, but above all, the non-stellar Deblur is better suited for galaxies and small deep sky objects, where the classic Deblur struggles much more. Now let's see what happens in the most aggressive Deblur mode if we go beyond the value 2, which is still not recommended. However, in defined mode, Parallax handles more extreme Deblur settings much better. Later in the video, we'll look at an edge case where Parallax's full potential really comes through. As you can see, Parallax Deblur is very powerful even on small deep sky objects. It recognizes small objects and performs a seeing inversion. As described in the paper, Parallax was trained using degradation algorithms based on real public seeing data from recent years. This means the inversion effect used during training is realistic, stable, and reliable. As I mentioned, defined mode is recommended when working with high focal length deep sky images, or when there are galaxies and small objects in the background. As you can see in the video, classic mode struggles much more with small objects. Now let's try processing Georg's image completely in defined mode. In the meantime, I'd like to clarify something very important. Some criticism has been raised about Parallax editing images as TIFF files, but that is not how it works. Parallax imports the floating point image data from Siril, SETI, or PixInsight. The AI inference is performed directly on those high-precision numerical values, and the result is then applied back to the original image data. So Parallax does not force the image into a TIFF workflow. If you are working in FITS, it remains a FITS-based workflow. If you are using another supported format, Parallax respects that as well. This is important because, in astrophotography, preserving float data helps protect faint signal, dynamic range, and fine details without unnecessary clipping or compression. Now that the inference is complete, we can see how Parallax Defined has completely removed the seeing blur from the galaxy. The small details have been preserved and made sharper, while the broader structures are now more clearly defined. To apply the data to your source file, simply click Apply to Siril. This new floating point data processing system is already available in the Axiom V3 Studio Beta and in Deep Prism V2, which will be available this week. Now let's try Parallax on a very extreme case to show you its full potential. Since Parallax was trained on real seeing data, it is also able to handle situations involving slight defocus and other optical defects. We are proud of what we have built, but even more excited about what we are creating next. Artificial intelligence is evolving quickly, and we are evolving with it. New models, new technologies, and new tools are already in development. Subscribe to the channel and stay connected. This is only the beginning.